So let's go ahead and solve some exponential and logarithmic equations. So as we all know by now that exponentials and logarithms are inverses of each other. So we're going to need that in order for us to solve these equations. So let's go ahead and dive into the first set of problems, the logarithms, and then we'll do the exponentials. So let's go ahead and for all of these, let's solve for the variable y in terms of t. So for number 1, we have ln of y is equal to 2t plus 4. Well, we know that ln has base e, so you can write the little e underneath ln as a subscript, but you don't have to. We know it's base e. So from definition of ln, we know that ln of x equals y. That means in exponential form, this is e to the y equals x. So I'm going to use this definition to rewrite this equation since I have, so this is kind of like my y and this is like my x. So I can rewrite this as e to the power x equals to y. So let's go ahead and do that. Now x and y are just dummy variable in the definitions. But know that this can also be written as e to the power 2t plus 4 equals y. And there you have it. By definition, this is already solved for the variable y. Now let's go ahead and take a look at example 2. So for example 2, again, we're solving for y. So same instruction. We have ln of this input y minus b is equal to 5t. So regardless of what t and b are, in this case, assuming they're positive, we want to solve for y. So again, using the definition, think of as this is your x, this is your y. So you have ln of x equals y. By definition, on above, we can say that this is simply, by definition, this is e to the power. So this is the power, that's 5t equals the input. That would be y minus b. And then last thing to solve for y, we can just simply go ahead and add this number b to both sides. We have e to the 5t plus b is equal to y. So there you have the y isolated again. All right, now let's go ahead and try out the last problem from this ln portion. The third one, we want to, again, solve for y. You're given ln of y minus 1 minus ln of 2 is equals to x plus ln of x. Now for the previous two, you do want to check your answer. I'm kind of avoiding that right now, but you do want to mentally check it. When you plug this into the input, does it give you a positive result? Yes, this is going to be positive. And the second one, you have 5 e to the 5t plus b equals y. If I insert that in here, I get ln of e to the 5t plus b minus b. So the b cancels out, you have e to the 5t. And that will cancel out, you have 5t equals 5t. So it checks. So make sure to do that check if you're solving logarithmic equations. It's important that we do this. Now I can go back to number 3. So we're solving again for the variable y. Now every time you have more than one logarithm term involved, you want to put them all together using the laws of logarithm. I'll link the video for that underneath in the description box so you can check it out. So by laws of logarithm, I know this, it's going to be turned into a quotient. So we can write this as ln of y minus 1 over 2 equals x plus ln of x. Now again, I see another term involving ln here. I can move that to the left hand side and then I can use laws of logarithm again. So you have ln of y minus 1 over 2 from before minus ln of x equals x. Now again, I see there is a minus. I can turn this into a quotient. So this will give me ln of y minus 1 over 2 divided by x, same thing as multiplying it right here, is equal to x. And now I can use the definition. So again, we know that ln of x equals y means e to the y equals x. So that's the definition. I know this is kind of like my x, this is kind of like my y terms in the definition. I can rewrite this in exponential form as follows. This would be e to the power x equals y minus 1 over 2x. And now algebraically we can solve for y. Let's go ahead and multiply both sides by 2x. We have 2x times e to the x equals y minus 1. Add 1 to both sides, we have y. 2x times e to the x plus 1 equals y. Now again, you want to double check your answer that this is all positive when you check. So if I plug this into this component right here, I want to make sure it's positive. And doing the mental check, as long as x is positive, this is going to be positive. So we want to make sure x is greater than 0. All right, so that's for logarithms. Now let's go ahead and dive into the exponential equations. So here we're solving for the specific variable. For the first one, we're going to solve for the variable k, and for the second one, we're going to solve for the variable t. All right, so for the first one, I have exponential in there, so I need to involve ln somehow. So we know that e to the 2k is equal to 4. So if I now apply natural log on both sides, because exponentials, their inverse is natural log. Apply natural log on both sides, and this gives me ln of e to the 2k is equal to ln of 4. And then again, by laws of logarithms, the exponents can come forward. That's 2k times ln of e equals ln of 4. And you should all know by now that ln of e is 1. That's one of the property of ln and natural log and exponential. So we have simply 2k is equal to ln of 4. And finally, I can divide both sides by 2. K is equal to ln of 4 divided by 2. Or if you want to be fancy and rewrite this answer, you can also do that. So this can be written as 1/2 ln of 4, or simply ln of 4 to the power 1/2, which is simply the square root of 4, that's ln of 2. So you could write your answer this way, or just leave it in ln of 4 over 2. Now let's take a look at the last example. For this one, number 2, we want to solve for t. So we're given e to the 2t minus 3e to the t equals to 0. And we're solving for t. So it looks like we can make a substitution, since I can rewrite this as e to the t to the second power 3e to the t equals to 0. So if I make a substitution, let x be equals to e to the t, I can translate this into a nice quadratic equations. So it'll look something like this. So e to the t is replaced with x. This is simply x squared minus 3 times e to the t, that'll be 3x equals to 0. Nice quadratic. We can solve it by factoring. I can factor out an x. I have x minus 3 equals 0. Then we set each factors to 0. We have x equals 0 and x equals 3. So we have 2 separate solutions for x, and that makes sense. Now you can do the quick check for this. So I know x equals 0, plug this in here because we're looking for a solution in t variable. So I have 0 is equal to e to the t. Now will e to the t ever be 0? If you remember the exponential graph, it looks something like this. Y equals 0 is the horizontal asymptote. This point is 1. So e to the t is never 0. Therefore, this function, this wouldn't be a solution. Now what about the second one? 3 equals e to the t. So can that be true? Well, yeah, right? So I can solve for t by simply taking natural log. So I know ln of 3 is equal to t. So that's the only solution. So once you find your solution in the x variable, simply go back, because this is where our solution lies in terms of t variable. Plugging it in, making sure it makes sense. Right, so that's it for this video.